Okay, so I do have the opportunity here to now turn back to neurological data and look at two studies. I already mentioned one, the 2007 study, our 2007 study, that look for deficit lesion correlations as a function of task. Remember, I told you I was going to defer discussion of two of these papers till later. That's because they introduced task. So one of them is an acute study, 53 patients, where the size of infarction and hypoperfusion in Broca's area and 12 other Brodmann areas was measured. The authors were some of the few that either read or were influenced by my papers on task effects. And they took seriously the idea that testing patients on one task wasn't good enough. So they used 10 reversible and 10 constrained sentences, active, passive, subject, cleft, and object cleft, 10 of each type. And they considered performance, there to be a syntactic comprehension deficit in a task if performance was at or below chance on passive reversible sentences on at least one task, accuracy on, I think the same for object cleft. And I mean, I know the same for object cleft, the slides are wrong. Accuracy on passive sentences was 10% lower than on active sentences. But if you think about it, that means one sentence lower on passive sentences than active sentences. And then, as I say here, okay, the same for object compared to subject cleft sentences. And performance on reversible sentences had to be 10% higher than irreversible sentences. That, sorry, just testing your level of vigilance, that's the opposite way around, of course. Sorry. Okay, so what did they find? That perfusion lesions in the angular gyrus were associated with syntactic comprehension deficits. There was a trend for the extent of perfusion in Brodmann 45 to show similar effects, so lower performances on reversible passives in sentence picture matching and object manipulation. And they claimed that the effect of the lesions in the angular gyrus in BA Brodmann area 45 is task independent. I'm not buying, because the difference between performance on the syntactically complex and the syntactically simple sentences is just too small for me to accept that as a valid dissociation. Our study, I went through this before. There are these three types of syntactic structures when you collapse across all the sentence types. We looked at a syntactic complexity score, which was the mean of the passive minus active and object minus subject extracted relatives, where a higher score means that people are doing better. And we looked at enactment, sentence picture matching, and grammaticality judgment. We looked at 4 perisylvian regions of interest and 2 non-perisylvian regions of interest, and the syntactic complexity score was negatively correlated with percent lesion volume in the posterior superior temporal gyrus, the inferior parietal lobe, the anterior inferior temporal lobe, in object manipulation when we measured lesions using MR, and it was correlated with the extent of hypometabolism in the inferior parietal lobe and in the entire perisylvian cortex using FDG PET, in object manipulation, in sentence picture matching, total lesion volume and total subcortical lesion volume predicted the syntactic complexity score, and metabolism in the insula predicted the syntactic complexity score. So effects of lesions in different areas on the syntactic complexity score in different regions of the brain. And this paper that is in press, I showed you the online self-paced listening data, and I'm going to show you the end of sentence accuracy data for the three tasks. Again, the measure of syntactic comprehension here is not a difference score. It's the performance on the accuracy measure, the accuracy on the baseline sentence, which is used as a regressor in the equation, where we also include total lesion volume times since stroke working memory. And now the critical variable of interest is there a significant amount of variance associated with lesion volume in a given region of interest after all these other regressors have been entered into the equation. And we also, before we said that we were going to accept that, let's see, right, if we were going to say that an area of the brain was involved in syntactic comprehension in just one task, we insisted that the unique variance associated with lesion volume was not only was significant in that task, but that it was the difference in unique variance associated with that variable in two tasks was moderately large to strong by Cohen's criteria for the amount of variance that is accounted for by an independent variable in a regressor. So the results. There were no areas of the brain in which lesion volume was a significant predictor of performance on any of the experimental sentence types. There were several areas of the brain in which lesion volume was a significant predictor of performance on a sentence type in one task. So for instance, lesion size in the posterior superior temporal gyrus, roughly Wernicke's area, was a significant predictor of performance on passives, again, after performance on axis has been regressed out. And the difference in unique variance between object manipulation and sentence picture matching in that area was large. Okay, so these are a small number of areas in which there is evidence for the involvement of that area in the combination of assigning a particular syntactic structure and using the product of the comprehension that depends upon assigning that structure to accomplish the task. And I should just mention that there's no effect of lesion size in these ROIs on self-paced listening times. The effect of lesion size on self-paced listening times, as I showed you later, were all in other regions of interest. So I'm going to say one thing that's outside the box, and another thing that's close to the edges. The thing that's outside the box is that I'm going to suggest, just because I'm prone to making outside the box suggestions, that these data invite you to consider a new way the brain might be organized to accomplish integrated tasks. So clearly when we learn to drive a car, or I don't know, let's say listen to someone give us instructions about how to fix a flat tire or something, we develop a set of skills that integrate different psychological domains, let us say, or functional abilities, visual perception, motor action, comprehension of language. And we can develop very, very highly autonomized areas of the neural mechanisms for accomplishing those skills. I mean, think about how rapidly a skilled piano player plays a piece, sight reads a new piece. It's almost, I think, universally thought, I think it's just assumed, I always assumed, that the way the brain did this was by having, say, the motor areas of the brain become very good at moving your fingers if you're a piano player, and the visual areas of the brain become very good at extracting the relevant aspects aspects of a score, and these two areas developing some kind of connection. But this suggests that another way the brain might become specialized for combining tasks is by dedicating particular areas of the brain to accomplishing them both. So this area of the brain, say the posterior superior temporal lobe, could become specialized for both understanding passives and mapping using the algorithms that assign passives to establish meaning to inform the motor system. That's a huge leap, but there's an old professor of mine who says better to be interesting than right. So I'll just throw that out. What I think is a little bit probably inside the box or close to the edge is that the fact that there's no effect of lesion size in these areas on self-paced listening times, but there is on accuracy, kind of establishes a temporal window during which the operations that are affected by lesions in these areas occur. They occur after the individual presses the response key to hear the next word in the sentence, and before that individual selects a response for the task. And this, the fact that this window follows incremental processing is consistent with the view that lesions in these areas affect operations that select responses in a task on the basis of both the meaning of the sentence and the syntactic structure. That is, that the lesions do not affect a syntactic operation per se. They affect something that is involved in a choice that is based not just upon syntactic analysis, but upon the meaning. Okay. I will do the one of the two others because even with 2 hours it's going to be too much. Okay, second deficit analysis. Interference from alternative interpretations. So this relies primarily on work from the visual world paradigm. Mike Dickey, I think, was the first to publish a full paper on this. He looked at eye fixations on items that were referred to in discourses, and he looked for an object fixation preference at the verbs of WH questions. And the basic finding was that people with aphasia maintained normal fixation patterns in sentences that they interpreted correctly, and they had abnormal fixation patterns in which they reverted to looking at the subject in sentences in which they made errors. So here's the paradigm. People are looking at an array that looks like this, with a boy and a girl and a door and a school, and they hear a scenario of the following sort. This story is about a boy and a girl. One day they were at school. The girl was very pretty, so the boy kissed the girl. They were both embarrassed after the kiss. Who did the boy kiss that day at school? Because it establishes a set of reference, gets you to move your eyes around. Hopefully people are not looking at the boy or the girl just at the beginning of the who did the boy kiss that day at school. If they are, those trials are eliminated. And here is the pattern of eye fixations plotted as the relative number of fixations on the object compared to the subject at various points in the sentence. So the first point is the sentence is, who did the boy kiss? And you can see that at kiss, both aphasic patients and controls, aphasic patients are here, I can't see the colors, are in black, and the control are in gray, show object gaze preferences of the same magnitude. When you get to the next phrase, that day at, the normals maintain their object preference, and the aphasic individuals begin to lose it. When you get to the end of the sentence, the aphasic patients have totally lost their object preference, and the controls continue it, and then in the period before they make their response, there's no object preference in the aphasics, but there is in the subjects. Now, if you break down the aphasic performance into performance on correct sentences and sentences in which they make errors, so the correct sentences are now in black and the errors are in gray, what you can see is corresponding to this black line over here. Both correct responses and errors show the normal object preference at the verb of the object extracted relative. Errors begin to that's right. So there's a sorry about that. There's the beginning of a drop here. Oh God, sorry. There's a beginning of a drop in this case for the correct subject. For the correct items at the phrase after that, but what happens, I don't think there's a significant difference between performances here. There's a very significant performance here. So when a subject makes an error, they tend to look at when a patient makes an error, they tend to look at the subject of the sentence, and that is what they choose as the interpretation of the object relative clause. The conclusions that Dickey and his colleagues drew were that when people with aphasia respond correctly, they're assigning structure and interpreting it correctly. That is, and that parsing. They were mostly concerned about a theory about that said that parsing and interpretation is delayed, which is something I might talk about later, but I won't. They argue this is strong evidence against any delay analysis of the deficit underlying parsing and interpretive failures. They, I think at one point they went so far as to say the parser is operating normally. What I want to point out is the late abnormal look to the subject of the sentence in the errors, which has been replicated in Dickey and Thompson for object extracted relatives, and also found for pronouns and reflexives in 2 other papers by Cindy Thompson and her group. Now, the results are different when the task involves fixation not on individual pictures of individual items, but on pictures of thematic roles, so sentence picture matching. Sandra Hanna and her colleagues looked at eye fixations in sentence picture matching. In German scrambled sentences, the father accusative is catching the son nominative. What they found was that in correct responses, there is a look towards the appropriate item, the item that is going to be the subject of the sentence early, but that in incorrect responses, the abnormal looks begin at the verb, not at the end of the sentence, at not necessarily the first point at which one might have assigned structure, because one could assign structure based upon the case marking in the subject noun, but at the first point at which normals begin to show an effect of structure on eye fixations, errors are already abnormal. What's the difference between the sentence picture matching task and the standard visual world paradigm that could lead to early abnormal fixations in sentence picture matching and only late abnormal fixations in the visual world paradigm? Well, in what my thought is that in the visual world paradigm, interference from thematic roles that are assigned heuristically can only occur late. You can't, there's no other source of thematic roles other than the incremental interpretation of the sentence. But in sentence picture matching, there's an additional source of thematic roles, which is coming from the picture itself. And in all of these paradigms, the pictures are visible before the sentence is presented. And so people are subject to interference from thematic roles that are derived from the picture early, and they show interference early in sentence-picture matching, but they only show interference late in the visual world paradigm. You get something like these results in self-paced listening. So I went back and looked at our self-paced listening data. What we said in our 2007 paper was that in self-paced listening with sentence-picture matching, we found a normal increase in self-paced listening times for passives versus actives, and cleft object versus cleft subject, and object versus subject extracted relatives in correct responses, and abnormal self-paced listening times at the critical verbs of those sentences in errors. We didn't ever publish the corresponding pictures, and I've never gone back to draw you graphs, but I'll show you graphs from 61 patients that we studied more recently and that were just published in Cognitive Neuropsychology. And you can see that the self-paced listening times for the verbs of baseline correct sentences, these are object extracted relatives, are fast relative to self-paced listening time for these verbs in correct responses, and that errors are associated with much longer self-paced listening times. So the abnormality that shows up in errors is showing up at the point at which the parser is encountering a load. But in grammaticality judgment, which we did in 2007, where there's no picture, the person only has the spoken sentence as the basis for assigning any kind of thematic roles. There was a normal increase in self-paced listening times for these same sentences in both correct responses and in errors. And here I do have the graphs, and these lines are the lines for correct responses and errors. You can see they don't differ. So again, it's the same phenomenon. When the picture is present, there are thematic roles that are available from the picture that begin to influence the operations of the parser, at least the behavioral correlates of what we take to be the operations of the parser early. When there's no external source of thematic roles to interfere, you don't see these effects, even though later on these patients are making errors for some reason. So I'm going to suggest, same thing, that in sentence-picture matching, continuing thematic roles arise early in effect processing, early in errors, and grammaticality judgments, there's no external source and they don't. So I'm going to stop here and just say that this would also be a control problem. It has to do with the, at least the response selection, if not inhibition, of thematic roles that are not grammatically licensed. Again, you see sort of the issue of task effects raising its head, but the point here is that the pathological mechanism is a failure to discount or actually inhibit unlicensed thematic roles, not necessarily a problem with the parser itself. There's a whole other line of research that leads me to suggest that another mechanism might be something I want to call resource reduction, but I'm going to stop because it would take a long time and I'd like to leave room for questions. I would just say that the idea that vascular aphasic patients, all these patients have strokes, have problems in the way the control system interacts with the functional architecture of the language processing system has been proposed by Landon Ralph and his colleagues in England for word comprehension. So they have contrasted the performance, and tasks that involve lexical items, not just comprehension. They have contrasted performance of aphasic patients who have had strokes and patients with semantic dementia, a progressive disease that affects nominal concepts. And what they find is that aphasic patients show abnormalities in tasks that require semantic processing, picture naming, sentence picture matching, categorization and grouping like pyramids and palm trees and the verbal equivalent of pyramids and palm trees. And so, of course, do the semantic dementia patients. That's the criteria for their having the diagnosis. what happens in the semantic dementia patients is that performance correlates not only within tasks of the same type, like let us say pyramids and palm trees for words and pyramids and palm trees for pictures, but across tasks of all types. So between pyramids and palm trees for pictures and naming, and pyramids and palm trees and naming and sentence and word picture matching. Whereas in aphasics, tasks that share task demands, like matching something to a picture, whether it's picture verification or picture selection, performance correlates highly, but performance dissociates, has very low correlations across the aphasic population in tasks that have different task demands, even though performance of the group as a whole in these different tasks is very low and equivalent in the various tasks. And his argument is that in vascular aphasia, what's deficient is the interaction between the ability to set up the functional architecture or somehow utilize the functional architecture and the particular operations that are involved in semantics. It's not just a modality-independent semantic deficit. So in these two areas of aphasia, I think that we are developing increasing reason to believe that the deficits may actually lie outside the language system, maybe not completely, but largely. If that's true, of course, then what we are localizing is deficits in these control systems or their interactions with the language processor, not in the language processor itself. So I'm going to leave it there, and maybe we have time for questions.
For the 2 hours mark, you have 40 more minutes.
40 more minutes. But I think
I'm just saying.
if I spend another, I mean, if we run out of questions and you want to hear about resource reduction, you just have to push the button and
That's a really interesting talk, and it's very worrying. So, is the language faculty in the cloud? I mean, how could it be so protected from brain damage that it never itself is affected, but only the performance links to other things?
That clearly can't be the case, but it could be the case that some very situated view of language is correct. That whatever the representation, however language structures are represented, they are neurally bound up with the operations that actually use them, and not just use them in the abstract to assign a semantic interpretation to a linguistic form, but the operations that use that semantic interpretation to generate action. That doesn't mean that there isn't such a thing as linguistic representations. I mean, it does mean that so one thing about this is that I don't want to claim that these deficits are purely executive deficits. They can't just be purely executive deficits. They're showing up in the ability to use certain structures to accomplish particular tasks. They have to be interactions between executive deficits and these structures. So it's very likely that there's something vulnerable about the assignment of these structures. But I found it hard to tease that out. I think we have to keep looking for, I think that one reasonable research program is to look for domain, task-independent structure or construction-specific online deficits. But we can find online deficits. We can find, we haven't found offline task-independent structure-specific. That doesn't mean they don't exist. It just means that no one's I think, provided convincing evidence for them yet. And I think that, if you want to push the system, what you want to show is a deficit that you can reasonably attribute to an operation of the parser online in more than one task, and then see if you can correlate those with brain lesions. That's a huge undertaking because they're obviously not going to be common. And it may be that we're looking at the wrong population. I mean, so it might be that we should be looking at the progressive neurological diseases, like non-fluent primary progressive aphasia, or maybe logopenic primary progressive, or maybe even semantic dementia, where people have said, so far that they haven't found syntactic deficits, but no one's really looked for them online. So, it may be that the nature of the pathology is critical in generating, because the effects of stroke are felt at a distance, not just locally. Now, of course, the effects of degeneration are also sometimes felt at a distance, but in really very, very different ways. So, there are, it's got to be in there somewhere. But
Can I suggest the pineal gland?
you can suggest whatever you like. I would say, remember something that Chomsky said a long time ago, you do get to make inferences based upon what you know about a substance, right? So you could look at a brick and say, well, that's not likely to represent language. And I suggest that the pineal gland is not a good place to look. Andrew?
Okay. Is it on?
It should be. Yeah.
Okay. I can't hear myself any louder.
No, you never do. Whatever. Does everyone else hear?
No.
I think it picks up in a minute. It's very smart
It
microphone.
is. Oh, wait. Should you turn it off? Yeah, you switched it off.
Oh, I see. Okay.
You hear the
Yeah. I won't
So
touch
hold it
again.
not too close.
Okay.
And you'll.
Okay. So I'm wondering, so this idea of task effects, it's also existed in the neuroimaging literature as well, and there's lots of debate about what is the right task, should there be a task? Do tasks just increase these executive functions? You're looking at executive function effects. So I'm wondering if an alternative is, and you went through this a bit fast, is looking at so you said that there's no task in which they have problems on these sentences across all tasks. But can we go back to that slide where you showed us the tasks that they did have problems with? Is there one task that is more consistently showing problems?
Object manipulation shows more common.
So I'm wondering if you have any, if you would say that maybe one task is poor and that's why you're getting this variability, or you think they're equally good tasks at looking at language processing.
I think, one task is poor. The reason these tasks were selected,
The reason these tasks were selected is were object manipulation and enactment and sentence picture matching is because they require comprehension. And they were contrasted with grammaticality judgment because it was thought that grammaticality judgment could be done basically entirely on the basis of an uninterpreted parse. That's the Linebarger interpretation of their data, which has kind of stuck, although I think it's probably a little simplified. But is object manipulation a better or a worse task than sentence picture matching? I would say no. I started using object manipulation. Did you want to comment on this right now, or do you want?
I'd like to, yeah.
Oh, go ahead.
But I want to let you finish.
Okay, so I'll try to finish quickly. I started using object manipulation in 1979, I guess, when I went to UMass and ran into Tom Roper, who was using it with children. And he didn't use sentence picture matching because it was too difficult to have artists draw so many pictures, which is actually a good reason for not using sentence picture matching. Also, another good reason for not using sentence picture matching is that if your artist moved to the West Coast, you could never add a sentence type because there are no two artists that draw pictures exactly the same way. and I'll mention one other little methodological detail. If you ever decide to do anything with spoken language, record those stimuli yourself, because if your voice moves to the West Coast, that's the end of being able to record, to do any more sentences using those stimuli. He had all kinds of extremely interesting results about syntactic development in children using object manipulation. There were a lot of people who were very skeptical about, I mean, not just a lot of people, everybody was very skeptical about being able to use object manipulation with patients, but there's really no problem at all. I mean, we have inter-observer reliability of 0.95. I mean, in our first papers, we published all those data because no one would believe us. So is it better? Well, it's different. I mean, the task demands are to somehow conceptualize an action and also to conceptualize a symbolic representation of that action using some kind of object, which is very different than the perceptual analysis of the scene, including the analysis of the participants in the scene and their interactions, and then mapping that onto the comprehension. But is one better than another? No. Object manipulation tends to be harder. I mean, consistently, scores are lower on object manipulation, and often significantly so. But better? I mean, what we need are...
I guess I mean tapping into what you want to be looking at.
Well, what you want to look at is whether people understand the sentence. Okay, go ahead. Obviously, there's something here that I haven't thought of, and that you two have. So, what is it? What am I missing?
So this is something I really like your talk. So this is something I became increasingly interested in. Is it on? Can you hear me?
I can hear you, I don't know
Yeah.
if it's on.
So I became more and more interested in the relation between task effects and the particular linguistic structures you're looking at, right? So I don't have much to say about object manipulation because I never thought about it, but I have data that talk somehow to the distinction between sentence picture matching and eye tracking with the visual word paradigm.
Yes.
So specifically, so it's very restricted, but it's specific for relative clauses. Now the data I have, I don't use either technique. It's self-paced reading. But what we show is that by manipulating the matrix verb with a relative clause embedded under it, we change comprehension patterns in healthy adults. And we change them in different ways across languages. So what we show is basically if you have a matrix verb that can take an event as a complement.
Can take a what as a complement?
If it can take an event as a complement.
Okay.
So like see, for example, I saw John running, this kind of thing. You see a massive difference between subject and object relatives.
Okay.
In French.
Okay.
And if you take a verb that unambiguously selects for noun phrases, like John lives with the boy, that, blah, 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 in these cases, you don't get a significant difference in comprehension between subject and object relative. And we looked at this distinction because what looked like subject relative in French under perceptual verbs can also describe events. Okay, so if in French you say j'ai vu Jean qui courait, or j'ai vu le garçon qui courait, this can denote a relative clause or what is called auxiliary relative. So I saw the event of a boy running, right? And how this ties back with sentence picture matching? Well, it ties back with sentence picture matching because typically when the task is done, you're presented with two events. And so you have to choose between two events, right? So there is a very natural interpretation that comes out with subject relatives in languages that are like French, in which you say, show me the boy that kisses the girl. You can very naturally be saying, show me the event of the boy kissing the girl, right? But when you have this alternative interpretation is not available with object relative clauses. So under perceptual verbs, an object-relative clause can only be an object-relative clause, right? Yeah. So there is a problem with sentence picture matching, which is I might have my subject think that I'm asking to select events, but I'm actually asking to select individuals because that's what
You're
relative clauses do.
you're actually asking them to do what? I'm sorry?
Well, when you ask,
I just didn't hear the last two words.
An individual, select
Oh,
an
yeah,
individual.
okay, right, yeah.
But so if I ask you, show me the boy that the girl kissed, the only possible thing I'm asking you is show me the individual, which is such that a girl kissed it, right? And this kind of problem, so that this ambiguity between show me an event and show me an individual does not happen with a visual world paradigm. But
No.
all you're showing is individuals,
Yeah.
right? So there is an interaction between the task and the syntactic structure you're looking at, which can be very significant.
Right.
And we show that this problem does not only arise in languages that have this additional ambiguity with subject relatives, but also in English. Interesting in English, and that's possibly because those same verbs, those perceptual verbs, also select events in English. So we find this, a generalized lower performance with both subject and object relatives in English under perceptual verbs. I'm talking about healthy adult speakers in Southwest region. So I'm convinced that there's task-dependent effects. What I more and more interested in is how a particular task interacts with a particular syntactic structure.
Well,
I mean, I think you have, you've articulated a particular case where you can see in much more detail exactly how the task requirements and task conditions could interact with the parser. I think we need to think about that a lot more than we've been thinking about it if we're going, let me put it this way, people will think about whatever they feel like thinking like. But I think if we're going to understand what goes wrong with aphasia, the kind of data that I've shown you here suggests that we've got to think about that kind of stuff a lot more. Now, I don't think that makes sentence picture matching a bad task. It just makes it a task that imposes certain conditions. I mean, sentence picture matching is a good task ecologically if what you think it is measuring is the ability to map propositional content down to events in the world. I mean, it's not as good maybe as sentence video matching, but it's better than the visual world paradigm. So if you were a big fan of ecological validity, it gets a point, right? But it has its own set of requirements, and I think that the example you just gave is a great example of how they could be influencing online processing that we think of as parsing. I agree, if you were tracking eye fixations over pictures in those sentences, you might get very, very different results than in the visual world fixation paradigm. I do think that people are likely to start thinking about this. Well, I mean, there was some discussion earlier that I sort of, in relationship to my first talk about, what do people think are reasonable questions and whose concerns should people pay attention to? So should, like, linguists pay attention to concerns of connectionism about neural reality, given that connectionists have not really begun to model any of the phenomena that linguists have begun to describe and explain. There's a sociological factor in those decisions, and the sociological factor here is that a lot of people who do work on the normal parser, empirical work on the normal parser, don't really want to, they sort of want to think, I think, the way you were kind of suggesting the brain should work, which is that the parser or the language faculty sits somewhere and then other faculties use it. They don't want to think, just avoided thinking about task effects. I mean, just for one example, I mean, all the work on reading and eye fixations in reading has been used as the basis for modeling a modality-independent parsing. Whereas in fact, differences in input between the written and the spoken modality no doubt have huge effects on how the parser operates. I mean, it gets a very different set of information. You know, you don't find anybody who, you know, who would say that the self-paced reading literature or the eye fixation literature doesn't yield hypotheses about the parser that could be tested in the visual world paradigm, even though the modalities are completely separate. But I think you have to think about something. And these are good things to, I mean, to be interesting. Okay.
Thank you, Professor. I mean, definitely a very challenging set of data. I think it's fascinating to think. It made me think at the same time and maybe actually start to find a reconciliation between like at least current minimalism and some form of radical embodiment of some sort, approaches to cognition, which I always kind of thought was very kind of as opposing sides in a debate, and maybe the kind of data you showed us here kind of suggests that we need to we have to give up a certain certain ideas of modularity of language as we thought about it, at least in pre-minimalist times, and either not worry about minimalism, even though I think there might be some interesting thoughts, and definitely think differently. So I'll try to be a bit clear. So what you were suggesting about the fact, not suggesting that you were showing very clearly the relationship between task and putative operations or structures, linguistic structures, definitely for me kind of goes in line, maybe not exactly to the version of like localized regions that do function, you know, understanding of a certain structure for a certain action, but definitely in a somewhat vague way, but in line with general ideas of kind of embodied cognition or procedural approaches to cognition, where we're not anymore dealing with representations, but just with, you know, situated response kind of set of processes that are only relevant, you know, it only happen when there is actually some, you know, relationship between it, some input in the environment to some kind of a motor response, and that everything else we talk about, when we talk about relative clauses or about anything like that, are just, you know, that's the position I think that some people hold today, you know, with West Coast, maybe in the States, but I think it's interesting to think. And that seems to be very similar to what you were saying. I mean, to kind of a conclusion that can be made based on what you've been showing, that basically we just cannot find this singularity of a structure anywhere kind of in the brain. So that's interesting. And something that I've been thinking a lot when you look at minimalism over the last now almost 20 years and its later versions since 2000, you know, going to kind of what is left of specific language, specifically linguistic, in kind of Chomsky's recent thinking is very little. We're talking about like operation merge and maybe some notion of interfaces that allow for spell out, but things that if we follow, okay, the kind of tradition I have been raised in with Chomsky and Marantz, etc., those are involved everywhere, up down to the word level and up, you know, there's not like a place, it's not like those mechanisms are specific to relative clauses or extraction or movement. All those don't exist anymore in this theory. The theory, with respect to what is purely linguistic, is really minimal, right? And so in these approaches, it's not even clear anymore what would be the status of something like a head, you know, object relative clause. It's not in any way in that approach, and I admit this is not the standard approach to what language is by many people, but it's definitely what, you know, anyone doing minimalism kind of needs to assume. I think it's not linguistic in any strong sense anymore. So object relative clauses are a complex of many, many things, and among them a certain history of derivation that involves what might be the basic linguistic operation, which is, you know, merge, applied, and then maybe internal merge and so forth. We have those particularity. And in that sense, this kind of data is not, you know, it's just saying we should not even, you know, we are kind of not we're not looking at language anymore, so there's no point looking for a parser that is, because that parser that we're looking for is already, in that view of minimalism, is already a mixed bag of internal and external processors of language that, unsurprisingly, under this view, even though Chomsky would never said exactly that, but one could imagine that, involve, task-specific, situated, processes, and then will be different, and there's nothing to, for someone who believes in English, maybe that makes any investigation of where the language is very much uninteresting, because we're just looking, it might be everywhere, because maybe merge is just a much more it's not somewhere in your brain, it's just a certain capacity of human brain structure, which is actually much more global. Anyway, I'm rambling.
Well, there were a lot of really interesting thoughts in that. I'll just comment on. Again, we could go on for a long time, but you'll tell us when someone will tell us when we have to quit. I've always thought that one of the great powers of Chomsky's theory is in the abstraction away from individual constructions. And he said many times, there's no such thing as a passive, that it basically consists of a bunch of more elementary operations. And, in 57 he said there was a passive, but it's been, that was quite a while ago. I think that the research program that, as you get into minimalism, the number of operations becomes minimal. I think the research program then becomes, can you construct a set of stimuli such that you could find an abnormality that actually could be attributed to the loss of an operation that no one thinks is real, like merge. So I think there have been people who've tried to do that, but I can't remember who they are now, but I've either reviewed or read, but I don't remember which, a paper that I think it came out of the Friederici group, but it might not have, I honestly don't remember, on fMRI correlates of merge. But I think that the reason I don't remember it is that I didn't think it was very successfully done. So, in the first Sherlock Holmes story, Holmes walks around with Watson, and Watson tells him that the Earth goes around the sun, and Holmes says he's going to endeavor to forget that because he has a model of human memory consisting of a bunch of pigeonholes, and he has to fill them up with relevant information, like what kind of ash falls from different kinds of cigarettes, and it doesn't help him to know that the Earth goes around the sun, and he doesn't want to put it into a pigeonhole. So I was very influenced by that model of memory when I was 10, and I really do try to engage in active suppression of results that I don't believe. So I don't remember where that result was, but it does exist out there somewhere. But I think it's a very hard thing to do. Now, is it possible that there's some very simple abstract operation like merge that we just haven't found because we're always testing it in the context of particular structures and particular tasks, and what we really need to do is sort of triangulate across structures and tasks on merge? It's possible. And that everything else is kind of situated. Well, it's logically, it seems to me to be logically possible. I don't see why situated models of cognition are necessarily inconsistent with models that postulate a lot of abstract representations. What can be situated are I understand that that's how they're usually presented, but I don't see that they have to be. Maybe I've misunderstood them. But it seems to me that if you think of situated models as the development of particular skills, that in fact most skills involve the interaction between some kind of perceptual or perceptual motor set of operations and a set of representations. Surely piano players have very complex representations of music, not just the correspondence between what they see on the score and where the fingers are going to move. But those are highly specialized skills that no doubt are based in very restricted areas of the brain that have become specialized to that and nothing else. I mean, good piano players aren't necessarily faster at buttoning their buttons. One of the most dramatic things I ever saw in my life was Horzowski. He was 99 years old when he played at Sanders Hall. He was supposed to play on his 100th birthday at Carnegie Hall, but didn't make it to 100, or therefore to Carnegie Hall. Anyway, it took him, I promise you, 5 minutes to walk from the edge of the stage to the piano. And then he sat down and he played Chopin, Liszt, and Beethoven at blinding speed. And then it took him another 5 minutes to walk off. And you would say, well, he's played a lot of Chopin and Liszt. He's also done a lot of walking in his life. So, I mean, these are really highly conserved skills that obviously depend on really different areas of the brain, more or less independent of the amount of practice. So, I mean, situated cognition, I sort of believe in it. I don't think that means, Joel accused me yesterday of being a behaviorist, but I don't think it necessarily means I'm a behaviorist.
Okay, have we had enough? And should we go to lunch?
Lunch is open.
Let's do it.
All right.